Morning. So this is a pre-recorded video. I'm shooting this on a Saturday night. Tomorrow I drive with Samantha Thompson, the curator of Lowell Observatory, and we're driving to Palmdale, California, which is northern Los Angeles, just west of Barstow, about 6.5 hours. And we're going to meet up with our SOFIA liaison, Pamela Harmon, and she's going to bring us up on everything that we need to know to observe two, hopefully, SOFIA missions, one on Tuesday and one on Thursday. So I'll be pulling all-nighters Tuesday and Thursday nights. Hopefully I'll be able to get some good video footage back to you all on Wednesday for physics and at least on Thursday, and then hopefully some new stuff on Friday if all works well, and I'd even be able to Skype into class. We'll see when I get off the plane and how that goes. Since it is a mobile observatory, we will be flying all night and then sunrise come in. So we'll see how it goes. So first, for those of you that don't know what I'm talking about, this airplane right here is a retrofitted 747 SP. It's shorter than a normal 747. So here's a normal 747 that we modified. Notice how long the tail is. So if you were like going to fly to Tokyo or China, you might fly in one of these because it's a long range, can hold a lot of people, has 2 stories, a lounge up here. Well, this is a longer 747. Well, back before they had really fuel efficient engines in the 70s, they converted a 747 to long distance flights. This was the airplane that could go from LA to Tokyo nonstop. In order for them to do that, they had to have it lighter, so they shortened it up, kept the same fuel, the same engines, so it could go just as far. Well, they retired these SP models, and NASA got a hold of a couple, and NASA in collaboration with the German space agency DLR converted one of these into a mobile telescope. And so the German space agency built this telescope and installed it inside of the airplane. And so when it's flying, this door opens up and you can then image the stars at night. So this is a very peculiar shot of the door actually open in the daytime, which is a no-no. You have to be careful of the sun because the mirror and all that kind of stuff. So you really never see SOFIA flying in the daytime with the door open. But at night they do it. And it's so smooth that this is open air in here. It's not open to the cockpit or the rest of the cabin. There's a bulkhead here that keeps us separated so I won't get sucked out. But when they open this door, there's no turbulence. Even though there's an open window here, the airflow is so smooth, the aeronautical engineer is so smooth over this gap that you don't feel any turbulence. And so we have a model here. Tia Coppola built this for me last year, and notice she did a nice little thing of the telescope. This is a Schmidt cast grain style telescope with a primary mirror and a reflective mirror, and goes into the airplane like this, and this window is open. So aerodynamics are so smooth you don't even notice the turbulence, so they say. So why would you ever put a telescope on an airplane when we got perfectly good telescopes on the ground? Well, number one, SOFIA is built to fly above the clouds. The first letter is the S for SOFIA, which is stratospheric. And the stratosphere basically begins above the water vapor. So the troposphere, which is the first sphere of our atmosphere, is the weather sphere, is the changing sphere. It's where all the water vapor lives, hence all the clouds and all the action and the rain and that kind of stuff. Well, clouds keep you from observing at night. And so if it's a cloudy night, you don't do any observing. So for one thing, SOFIA can fly above the clouds. But more important, excuse me, is it's a stratospheric observatory. Observatory, just like Lowell Observatory, this has a big mirror. In fact, the mirror, the primary mirror here, is 100 inches, which is I'm about 6 feet, and that's about 72 inches. So 100 inches, like way up there. That's a huge mirror. That's a lot of light that it can collect. So very big mirror. So stratospheric observatory for infrared astronomy. Now, whenever you look through a telescope, I'll get one over here. The telescope, you're usually looking with your eyes, because your optic nerves are what is seeing. Woo! Well, SOFIA, you don't actually look through anything. Crazy. But it's looking at light that we can't see with our eyes. It's looking at infrared light. So I'll give you a little demo here. Some of you have seen this before. Here is a camera that is sensitive to infrared radiation, where our eyes are only sensitive to visible light radiation. So, turn this little guy on here, and let's see what's going on. So here is my image here. I'll put them upside down. There we go. There's my mouth. Great picture of me. See? Really hot parts of my body. My chin. Look at my mouth. Not so hot in the mouth. And then my shirt. So it's not leaking out too much heat. Now here's a crazy thing. Watch this. I'll put on these glasses. See? Can you see my eyes? Can you see my eyes? Look at this. Cool in shades of Men in Black. Check that out. They're clear glasses, but clear glasses won't let the infrared radiation from my eyeballs out. It's blocking it. Just like your car windows block the infrared. The visible light comes in, and your car gets hot because it's trapping all that infrared radiation. It won't let out. Now watch. Take the glasses off, and ta-da! There's my eyeballs again, releasing all sorts of infrared. Check out my eyebrows. Eyebrows aren't releasing the infrared. They're blocking it. Hence why they're black. My lips. Stuff too. So this camera sees in the infrared, and that's what SOFIA does. She sees in the infrared, and in order to see in the infrared, you have to get above water vapor, because water vapor absorbs infrared radiation. So the water warms up when it's in the sun. It's the infrared radiation that's warming the water up. Your pool water gets hot. Water on the ground gets hot because of that infrared radiation coming in. So, a lot of interesting things in astronomy are not in the visible light spectrum. And so, I've given you some handouts that I want you to look through. There's 3 of them. One is of a tour of SOFIA, in and out, and some of the cameras and stuff that's there. So again, this is the 747 SP. This is basically the telescope and the airplane. And then look right here. I'm one of these guys. I'm an airborne astronomy ambassador, and this is where I'm going to be sitting at this little chair right there. It's this cool little space right there. So that's where I'm going to be sitting. The other flyer here is what SOFIA sees. And so I think the most interesting one is this right here. And when you look at it, if you were to look at Orion, constellation Orion, right here, right here, and with your eyeballs, this is what you see. Of course, you don't see these blue lines. We've connected them. But if you were able to see in the infrared, you would see all of this exciting things happening in the infrared. So the infrared, we can see so much more. So here's the visible light spectrum. Here's all we see the visible light. All of this is what stars are releasing. And so with the different detector, we can see so much more going on with the electromagnetic signature. And so that's what SOFIA is looking at. It's looking at infrared radiation coming off. And so this does a really great summary of all the different things SOFIA can see. One of them really is the galactic center, how to see into our galactic core and evidence that there's a black hole there. So I don't know if I'll be seeing any black holes, but we're looking at some pretty cool stuff. Anyways, and that's more to come. So today's demonstration is just bringing you up to speed on what the plane is and the mission and whatsoever. And so I think I've talked about it, and I'll end this lecture for now and continue on later. Have a good day. Bye.